In this section, we are going to be talking about eruptions, and this question specifically, why do only some volcanoes explode? And it does depend on a few different factors that we're going to move through here. And one of those is temperature. So rocks actually can melt, which seems like a crazy concept to us, but if you get them to a high enough temperature, they actually can melt. They don't melt until, like the numbers your book puts there is about 800 degrees C to about 1200 degrees C. Well, this is the same thing as about 1800 degrees Fahrenheit. Well, your oven, if you have a typical oven in your home, it can probably get up to a max temperature of 500 degrees, and that's a max temperature, like if everything's really running right. So that's 4 times hotter, is how hot it needs to get in order to melt rock. Well, interestingly though, if you actually add water to the rock mix, the rocks will actually melt at a lower temperature than if they didn't have water. So instead of taking 1800 degrees, maybe it'll melt at 1300 degrees. And that depends what it's made out of. But the water actually makes it so it doesn't need quite as much heat to melt a rock. Well, as we learned earlier, you know that a lot of oceanic plates will subduct under a continental plate and it'll drag a bunch of water with it. And that water will help that rock, along with the pressure, boil and turn into magma. So that gets me to my next point, which is pressure. Pressure actually, as pressure increases, temperature increases, and so it helps the rocks to melt to be under a lot of pressure. And of course, rocks that are buried under the earth are under a great deal of pressure. The next thing that helps, that determines volcanic like magma composition is how much dissolved gas is inside of the rock. So if you have like a jug of water and a jug of soda and you shake both of them, the jug of water probably isn't going to explode when you take off the top because it won't have very much dissolved air in it. However, the jug of soda will have a lot of like dissolved air, like in the form of CO2 in this example, and it'll, when you take off the top, it's gonna explode all over the place. So the more dissolved air that you have, in other words, gases, the more it will explode. And types of gases are carbon dioxide, sulfur dioxide, hydrogen sulfide. All of these can dissolve inside of magma. The next thing that I want to talk about is viscosity. Viscosity is specifically an internal resistance to flow. So some things really don't flow very easily. When we think about things that flow, we think about like water or back to the soda. They just flow so easily. If you take a cup of them and dump them out, they flow easily out of your cup. But other things like mayonnaise or honey or glue, if you turn the whole bottle over, it either takes a long time to come out, or like if you did that to a bottle of mayo, there's a chance it might not come out for a very long time and that some of it will just permanently stay stuck inside. So that means it's very, very viscous, meaning it's resisting flow. So one thing that helps a substance resist flow is silica. So depending on how much silica something has, that determines how viscous it is. So specifically, silica content determines viscosity, and the amount of dissolved gases help determine explosivity. So something that's not very explosive tends to have a low silica content. It tends to be watery, and we call that being low viscosity. Something that's very explosive has high silica content, was sort of like kind of syrupy or like, something like that, and then it has high viscosity. So the more viscous the magma, the more explosive the eruption. So I'm going to ask you a question here and have you think about it. If you had a volcano that had a lot of dissolved gas, like a soda, and it also had a high amount of silica, making it very viscous, what kind of explosion would you expect? an explosion that would be safe and you could stand back and just watch it, or would it be a huge explosion? The answer would be, in that case, a very large explosion. So the amount of silica in the magma also determines kind of what type of volcanic rock it will form when it cools. So there's some different pictures here, and I'm sorry I have not navigated past the really good pictures that are here. But basaltic magma um, is less than 50% silica. It reacts very little with the continental crust or what it hits. It just kind of gently rolls out. Think about Hawaiian types of volcanoes that you can stand back and safely watch. You're not having to evacuate. They can make a little tower and platform for you to go watch the explosion. It's a very safe little cool volcano to go see. The next thing is andesitic magma, and that type is about 50 to 60% silica. It's from oceanic continental subduction, so you know there's a lot of water involved. So it's got an intermediate explosivity to it. So we might think, well, that's not that crazy, but the most dangerous volcano, or the volcano that's caused the most damage in recorded history, was actually one of these, because you know volcanoes can throw off a lot of ash and things that cause global cooling, and in this case this one hit, which was Mount Tambora, and it hit and caused a global temperature decrease of 3 degrees, and a lot of crops failed. A lot of people died because of starvation, because of lack of crops. And the last one is rhyolitic lava. It is highly viscous, so very sticky. It's formed under the continental crust. It's got very viscous, a lot of gas, and it makes huge explosions. So specifically, Yellowstone was this type of volcano. So when volcanoes erupt, what comes out of them can be different things, from ash to giant rocks, and this is all called tephra. So this is small tephra, this is big tephra. So it's what gets thrown out of a volcano. The last thing that I want to go over with you are pyroclastic flows. Pyroclastic flows are these giant, rapidly moving clouds of tephra that are throwing ash and rock and burning hot rock, you know, that can cause a lot of damage and hurt a lot of people. These are called pyroclastic flows. They're very dangerous. And interestingly, we've had a few volcanic eruptions throughout the world recently. So you might want to look up some of those and see what you can find out. Okay, that's it. Take care and have a good day.